Hi again, and welcome back to 2024 question B1. This was an intersecting planes question. So the image on the right shows a Virgin Media Sports Studio desk there. The desk consists of a truncated square-based pyramid which has been cut using an inclined plane. Okay, so we've got a truncated pyramid, which is a pyramid that has been cut horizontally, and then we've got this inclined plane that's removed another piece of material down here, right? So figure B1 shows the plan and elevation of a similar desk. So we've got our plan and elevation. We've got our 3D figure down here. So part A, draw the given plan and elevation of the desk. Okay, so plan coming first, so we'll start by drawing the plan. All right, if we look at our measurements here, we can see they're kind of large, right? And we've got this scale 1:15. So our measurements here, we're actually going to need to convert. So if I divide that by 15, okay, that is going to be 55. I'm pretty sure. 55. Yep, over here. And that's going to be 15. Yeah, it's 50. Okay, and 15 into that. That's 80. Okay, let me just double check that on the calculator. Yeah, so all of those are correct. All right, so I'm going to start with my outline of the truncated pyramid. So that top piece there, it's a square-based truncated pyramid, so it's a square here going around that. So a square side 80, and it's inclined at the 75-degree angle. Okay, so I'm going to pick a point here, maybe out there. That's going to be my starting point, right? And we've got that 75-degree angle. Now you could use your protractor to measure that, right? But if I combine, just to show you here, if I combine my 45-degree angle and add on a 30-degree angle, 30 degrees plus 45, I get 75. Okay, so that will save me a little bit of hassle. So 45 and 30 combined. Let's just draw my light line, and I'll measure 80 on that. Okay, and I can combine them here to get this line. The same, if I can get it to stay on the board. All right. So that's my 80 again marked off. And I'll combine them again for my final measurement, or my final edge. Okay, so that is the square that's on the top. We now want to mark off the internal part. So the hidden detail here of the base, which is 70 or 750, which is 50 there. So to find that, I'm going to actually draw a diagonal first of all. So draw the diagonal. Okay, and I'm actually going to draw a light diagonal from here to here as well. Right, now my 50 is the full width across there, so I'm going to measure 25 out either direction. So that's going to be, okay, so it's total 80, 50 is what I'm removing. So if I measure in 30, so 15 and 15, 15 and 15, that leaves me with my 50 there. Yeah. Okay. And I can use my combined set squares to start drawing those lines, finding those marks. Okay, so you can see here how having their two set squares together makes it all work a little bit quicker. Okay, and now we want to just finish off our outline. So we've got hidden detail in there, and we've got the join back to point P there. Okay, so that's the point P. Point P found. And we've got our other heavy edges for the top. Now we've got hidden detail. And the last piece of hidden detail. All right, now onto my elevation. So the only height I have here for the elevation is that 55. So let's just project up each one of those. We're going to have our baselines as well. Yep, and 55 high. Right, so I've got the outline of all that. I just need to add in what's heavy and what's hidden detail. So we've got the outside edge, side edge to here. That's my point P. And hidden detail line. And let's not forget the top. All right, and point P. Right, and we got surface A and surface B. So that is my plan and elevation. Just want to check everything. Yeah, completed there. Now, part B, determine the dihedral angle between the planar surface A and B. So here's surface A. There's A in there. And here's surface B, and that's surface B. Okay, so first of all, we need that line of intersection. So my line of intersection between those two planes will be this one here. So that's my line of intersection. And here it is here also, line of intersection. What we want to find then is the true length of the line of intersection. Okay, through an auxiliary view. So we're going to look out perpendicular to it, our x1, y1 out here, and draw our auxiliary view. And then we're going to find our point view. Point view of LOI. And that should find us our dihedral angle then. All right, so let me just highlight the line of intersection first there. Just get a little. So here's our line of intersection. and here it is. Okay, so LOI, LOI. All right, so we want to look at perpendicular to that. So here's my sliding set squares. Let's set up my x1, y1 parallel to the line of intersection. And we're going to project out all the points of surface A. And I need to slide this again. I need to find surface B also. Okay, so that's my x1, y1. Right, so I'm creating an auxiliary plan. So, sorry, auxiliary elevation. So I take my heights from the elevation. So we've got various points. So P, this is point P on the ground. This point is also on the ground. We follow it up, right? We've this point here, which is on the line of intersection. We follow it down, so I need to step off that height, which we know is actually 55, but it's good to have the habits of showing that with an arc. And we've also got this point, which is also a height of 55. All right, so let's draw up that surface A to begin with. And here's surface A as well. So that's surface A. Here's surface B then, and that's my line of intersection. Surface B. And let's just highlight the line of intersection here for you again. That's the true length of LOI. All right. So now I want to look along. So I've line of intersection, true length of line of intersection. Now I want to see it as a point view. So I'm going to look out along the line of intersection. So my x1, y1, or sorry, x2, y2, and I'm going to project out our distances, so our lengths, our points. All right, and projected them all out. Okay, so now we need to go back two views to get my line of interest, or to get my heights. Okay, remember, if you're ever if you ever forget this, right, we're looking to find a point view of the line of intersection. So whatever the distance is that I step out for this point, okay, whatever that distance is, it'll be the same for this point. If we go back here, we can see the distance for there is the distance for there. So I know that's where I'm going to take my heights from. X1, Y1, back. So those are the same distance. That's going to find me my point view. And then this point, step that off also. So I have to extend that line a little bit further. And finally, this point here. Okay, so extend that a little bit further. Okay, so here we have our point view of the line of intersection. So point view of LOI. All right, and we've got our two surfaces there. And did they say to indicate, determine the dihedral angle? Okay, they don't say to indicate it, but I'm going to measure it because it's a good habit to have. So, measure there. Got that at 116. Okay, so let's go 116 degrees is my dihedral angle. Okay, so that's part B completed. All right, my point view also completed. Okay, part C1, determine the angle of inclination of the surface B to the horizontal plane. All right, surface B, we're going to find its inclination to the horizontal plane. Okay, so we want to see surface B as an edge view and the horizontal plane as an edge view also. Right, so I'm just going to pause the video and highlight surface B for you. Okay, so here we have surface B highlighted for you. All right, if we look at surface B and what's the makeup of surface B, we have our line of intersection, we have this sloping line also, and then we have this line here. If we look at that line in elevation, that's a horizontal line. So I know a horizontal line, if I look down on top of it in plan, is a true length line in plan. Okay, so this line is a true length. If I look out along that true length line, I'll get an edge view of that plane. All right, so we are going to do an XY line perpendicular to the true length line. Okay, and this. All right, and we'll project out B. All right, just extend that a bit. All right, so I've got an X1, Y1 here. X1, Y1. All right, so we're projecting an auxiliary elevation. So my heights I need to take from the elevation. All right, compass. So P, here's P, so that's a point. Okay, this and this, if we follow them up, have the same height. So let's get that height, step it off. And now I've got an edge view of surface B. Okay, so here's my yellow guy. So that is an edge view of surface B. All right, and we have an edge view of the plane or of the horizontal plane. So they've asked us to determine the angle of inclination. So what I can do now is I can measure that angle between the two. So let's come along and measure that angle. I've got that at 57 degrees. So let's go with 57 degrees. All right. That's part one. Part two then, determine the true shape of the surface. So if I have an edge view of a surface, if I look perpendicular to it, so if I look this direction okay, or this direction, perpendicular to it, and draw an auxiliary there. I'll get the true shape of that edge view, or of that surface. So to put that on the page, I'm just going to go up this direction. So we want to project up. So my x2, y2 is up here. I'm going to project up that edge, that edge. Okay, I probably need to project this one a little bit further, I'd be guessing. All right, so once again, we're going to go back two views. So here are my distances back from the x from y1 back to plan. So let's follow my first one is that distance. Follow it up and up to there. My next distance will be from here to point P. Okay, follow that up. All right, I'll have to extend that line a little bit further, and finally my distance to the other side of that plane. Follow it up, I'll have to extend that as well. All right, so all right, so there's my plane B, the true shape of it. Okay, so that's a true shape of surface B. All right, so I can shade that in as well. Okay, finally then, we're on to the last part of that question. So tick that off. Draw the elevation and plan of a line on surface B. So on surface B, which is drawn from point P, right, on surface B, and it is inclined at 50 degrees to the horizontal plane. Okay, so this is a tricky bit in this question. We haven't seen something like this in a couple of years. So what we want to do is we actually want to draw a cone, okay, an inverted cone, so an upside down cone. If you imagine it's there like that, and that cone has a 50-degree angle on its generators. Okay, so if I draw that here, my 50-degree cone, okay, 50 degrees, so 50 degrees, okay, that cone, one of those generators will intersect this plane, okay, so imagine if I drew that cone down here, I'd see it intersect actually at 2 points. I get two generators there that intersect on that surface at 50 degrees. Okay, so that's what we're going to do. We need to measure an angle of 50 degrees. First of all, so 50 degrees from P. Okay, and I'm actually going to measure it in both directions, 50 degrees. Okay, so that's the elevation of that cone. And I want to draw it in plan, so I need the radius of it. So let's drop down here. Actually, maybe draw it down here. And there's the radius. And let's get our compass. set it to that radius. All right, that's the plan view of that. So now I have a point and a point, point. Okay, and I'm going to join that back to point P. So they're only asking us for draw the elevation plan of a point. So I only need one of them. I'm going to draw that one there. So all right, and I'll show that in my elevation as well. They're looking for plan and elevation, yeah. Okay, like I said, you could have another one here and project it up and draw it, but one is fine. If you want to show two, by all means do. Okay, so that finishes that one off, part D. Okay, so that was an intersecting planes question. Pretty straightforward, a lot of it. It's the last part D there we haven't seen in a bit, so that would have thrown some guys off.